What's going on, guys? Figured I'd throw a video up here for Greg Porter and whoever else wants to listen. A little Volkswagen stuff, a little morning vlog, morning chat thing. So Greg's rebuilding this 1600, which is really cool, and I'm gonna try to help him along with a few tips, and I'll go over a few things that I spotted when I was looking at your video this morning of you pulling your case down. So first thing we're going to do is I want to touch on positioning the rings and the condition of the cylinders as far as the piston cylinders. Now, Volkswagen motor, the beauty of a Volkswagen motor is it'll run no matter the condition. If the bearing isn't bad and it's got some kind of oil pressure, you can almost put any kind of parts together and end up with a motor that runs. However, we're looking for a little better than that. So we're going to touch on a couple things that make the motors drivable, and why motors run hot, why motors don't run hot, all that good stuff we'll try to hit on. Now, as far as the crosshatch and the cylinders, you want some crosshatch. This is a decent used cylinder. You can see that it still has some crosshatch in it, and what the crosshatch does is that controls the oil. That's where the oil sits in there, so the rings can be lubricated. You want to make sure that you don't have a lot of wear. You know, this one's about max. You can feel something down there, but I think they'll be okay. You know, I just re-honed them. Again, you know, you can almost put any combination of parts together and have decent luck. But get you a little ball hone from your local parts store. Let's see here. You got this type of hone is the best for you know, doing it at home. The hones with the hard stones seem to not really put a decent crosshatch in it. You know, these ball types seem to do a little better, but you know, use what you can get, but try to put a little bit of a crosshatch in there. And at least take the ledge off, so when you reinstall, you know, the pistons, you don't have any issues with breaking the rings. The other thing is, I talked about ring positioning the other day, and I don't know if people really understood what I was trying to say. Here's a Molly piston that's been in a motor for about 90,000 miles, and you can see the rings are completely shiny. They're worn out. You know, if you wanted to, you could take these off and put them in the cylinder and measure the end gap and see what kind of gap you have, you know. But from the looks of the faces of the rings, they need to be replaced. And rings are fairly cheap, so. But I was saying never put the ring gap over the wrist pin. And the reason why is if you look at this piston and the wear on it, all the wears on the top are the bottom. You can see all the mollies still intact on the sides, and that's because the piston is cam cut. It's not actually, you know, perfect circle. So when you put your ring over here, a lot of times, you know, you'll get in a situation where the ring's not sealing against the cylinder. So you always want to have your ring away from the wrist pin. You know, even if it's here, this far away is fine. And the other thing is, don't ever put the ring directly on the bottom of the cylinder, because a lot of times the oil will puddle in the bottom of the cylinder, and if you have the ring gap right center in the bottom, when you fire the motor up, it'll pass the oil there and smoke. So that's a good ring tip. Now the bearings, you were asking about the different size bearings. That case looks like it was probably a line board. To me, I don't know. You'll have to measure it, you know, or take it down to the local shop there, and they can probably check that out for you. But I got a couple bearings here. Let's see, I'll grab a couple that are good here. I got a big fat one. You can see this is the rear main right here, and when they line bore the case, of course, this circle gets larger. So you have to get a larger bearing, you know, to fill the hole. And then the other thing they do is they machine this surface as the thrust. you were saying it looks a little rough back here, you want to make sure your thrust bearing's nice and tight. You know, the bearing cannot move on the case. It needs to be tight back here. When you take the case down there, they'll measure the thrust, and they'll measure the line bore on it, and then they'll measure your crank. So you'll need to take your crank and your case with you down there, and then they can determine how much it's been line bored and how much it's been thrust cut. The bearings all have different thicknesses on the back side, so you know, depending on how much the case has been thrust cut, you can buy a bearing to accommodate that. The other thing you want to look at is this area in the mains. You know, you want to make sure that it's not really shiny, beat up. You're probably going to use the case anyway regardless, so that's why I always say, you know, put a larger oil pump, because this is where you lose oil pressure from. As this wears, you know, and squirms, loses oil pressure between the bearing halves. So the extra volume, the extra oil pump pressure, you know, makes up for all the leaks, internal leaks in the case. You're not necessarily getting the high volume pump for any kind of performance gain or anything like that. It's just to make up for the wear. The camshaft, you were wondering how you could check that. You can take a micrometer, you know. This is just a cam for an example, and you can measure lobes, you know, make sure they're symmetrical. Look at the condition of the lobe, look for pitting, you know, anything like that. You want to make sure that it's nice and smooth and has no pits. The lifters are a replacement item. You know, the lifters that you showed were worn quite a bit. They had the concave in them. Usually the cam wears in and it gets a little convex there, you know, as the cam wears. And if you're going to use the same lifters again, you need to keep them in designated hole. You can't mix these up. If you take them out of the case and you mix them up and you put them on the wrong lobe, it's more than likely going to have an issue. This is a reface lifter, and we have new ones over here in this other case. You know, like I said, it'll run with that worn cam. It's just, that's the power of the motor. When you start using used parts like that, you're not going to make the power you're expecting, because the camshaft, the piston cylinder sealing up and having good ring contact with the cylinders. Those are all the items that give you dependability and power. I usually try not to use cylinders unless they're pretty decent, because you know, you hate to put a motor together that smokes or whatever. This is what I consider a good used piston. You know, this was in a motor, and you can see it has very little heat on the back of it. You know, it didn't ever run hot, and running hot's the next thing we'll talk about, and that's the compression ratio. All Volkswagens are designed to run on 91 octane fuel. A lot of guys think that if their Volkswagen was manufactured down in Mexico, it has some magic compression number and you don't need fuel, you know, to run it on. You can run them on regular gas, kerosene, whatever. And that was maybe the case in 1973 when regular gas was gas. But since they've introduced alcohol into the fuel, most all Volkswagens, you know, suffer from that. The alcohol, you need to increase the jet size when you introduce methanol into the fuel. Volkswagens don't have an oxygen sensor, so there's no way for them to adjust other than you going in and manually making the jet bigger. And usually when you make the jet bigger, people aren't happy with the gas mileage that they get. So, you know, I lower the compression. It's the best way. A lot of people think their compression's low, but what happens is most of the times the motors have been rebuilt, the heads get machined, you know, the deck gets machined, and then everything gets smaller and smaller, and the compression actually gets higher and higher as the parts get used over and over again. So SCAT, if you go to their website, they sell the spacers that go between the case in the cylinder. That's this area here. Now if you have a larger displacement engine, 90.5, 94, you make a copper gasket that you can put on the top. Most people don't recommend the copper on the street. It's sort of a race deal, you know, where you're going to constantly retorque the heads. So the spacers are the way to go. You guys remember when we were building the 1915 motor, I bought 180 millimeter, or 180 thousandths thick spacers to go under the cylinder. The spacers are very expensive if you buy them from Remco. I know that Scat here, you know, they offer the spacers, you can buy them. These are 300. The problem is Scat only has them in different variables. You know, if you want custom spacers, you have to get them from Remco, and you're going to pay for those. Here's a couple different spacers here. There's some steel stock ones. I don't know how thick these are. I'd say they're probably 40s. Here's some for larger barrels. I keep them around. I use them all the time, you know, and that's why my motors don't run hot, and I'm not having issues. I bought the spacers for the 1915, but you know, not only do you have to buy the spacers, which are $100+, you got to buy the push rods, which are longer. So you get into buying a series of things, and you know, I always recommend spending that money because it makes the motor drivable. You can save the money, yeah, and the motor will run, yeah, but it's going to run hot, you know. So low compression is the key to no heat. A lot of people think that you take all the power out when you pull the compression. Of course, we have to do other enhancements if we're going to pull the compression out and still want to have power. You know, that's why we port the cylinder heads. That's why we put a little bit of a camshaft in there. And cam is another item that can make or not make heat. You know, I found that some cams have the favorable duration. Duration is when the intake and the exhaust valve are open at the same time. And when that happens, there's like a cooling effect on the motor. And I found that if I run a little more duration, I seem to have a little less heat. So that's why I like to change the camshaft. The stock cam is very good in the aspect that, you know, you can use stock valve train components, but you're limited to the power that you're going to make with the stock cam. You know, you can go in and change the rocker arms from 1.1 to a 1.25, you know, for a little bit of power if you don't want to put a camshaft in there. Performance cams come with no gear on there, so you know you have the cost of the cam. You have a $30 gear, and some people are turned off by that. But I really like the Scat C35 cam if you're going to build a little 1600 or a little 1776, something around town, you know, it's a good little cam. So like I said, you can put anything together and it will run. Here's another thing he asked about, was the hardware on the case. These are aftermarket nuts. You know, somebody's rebuilt that motor and they probably just used what they had. The 19 millimeter nuts are an upgrade. The sealing, the locking, you know, the nylock type. Factory nut was 17 millimeters, so that's what you have there is the factory nut. As far as the AS41, you know, that's basically the alloy of the case. This is the AS41. AS41 was used in a wide range of years. You'll see it on a lot of replacement cases. Best case, you know, if you're really looking for a case that'll handle some heat, is the AS21 case, which is the alloy that they use on the fuel injected motors. Hardware, you can get that at your local Volkswagen place though. As far as the motor having a tight spot in it, you need to figure out what that is. You know, you might have a burr on the cam gear. Take the cam out, rotate the motor without the cam in there. And before you try to put the case ass together, make sure the crank is sitting down in the case on all the dowel pins. You know, you should be able to take one finger and just rotate the assembly. and not have any kind of variation in the way it turns. So this is our 1600 we're building. It's rebuilt rods, new bearings, rebuild reground lifters and cam, and a new oil pump. And we got a set of piston cylinders over here for it, and we got to make some heads. So I hope I answered some questions. I don't know, I might have just babbled on. Here's a new aluminum case here that we're putting together, a spare, you know, and cam bearings. That's another thing I wanted to touch on. These Coleman Schmidt cam bearings are no good. Here's a brand new one. I've got a couple sets of them laying around, and you put these in the motor and you put the cam in there. It's got no end play. That's one thing I've noticed. End play is when you set the cam in the case. You know, that's the measurement of the cam moving back and forth. You have to have some end play. If you don't, you'll have issues. These almost make the cam not turn. So a lot of guys have told me they've been sanding these on the glass, making them have some thrust. But they have other issues besides not having any end play. They're made out of aluminum and they're tight. Anytime we have a combination of aluminum and tight, that's not good, because aluminum melts a lot faster than steel, and these new bearings, what they're doing is they're sticking to the parts. I've had some good friends that are very good engine builders. You know, they do everything exactly the same every time, and they're having failure because of the aluminum bearings. You know, the flywheel's melting to the shims, or the shims are melting to the bearing. You know, it's just it's not good. Use the silver line bearings if you can get them. They're still metal constructed, even though they're you know, not a German part. They are far superior to the Coleman Schmidt stuff. It's aluminum. Yeah, so you're going to check your gears real good. Make sure you don't have any burrs in your distributor gear, your cam gear, you know, on your rotation issue. Make sure all these dowel pin holes are in very good shape. Nobody pinched one and smashed the bearing or anything like that. Mark all these before you assemble the engine. And what I mean by mark them, I mean, here's your dowel pin. You're going to have all these assembled on the crank. This is the front bearing that goes under the behind the timing gear. So what you want to do is mark the dowel pin location. So when you're rotating this, trying to get the dowel pin lined up, you can use these for a reference. I usually put a dot on the top of the bearing also, so you can see it. You know, that's supposed to be the top straight up, and that's the bottom. You know, if you want, you can mark it top. You know, little stuff like that's going to make your assembly go a lot easier. I just lost the cap to my marker there. You want to make sure all your lifters go up and down and turn freely in your case. They have to rotate, not to wipe out. And I think that's about it. I think that's all you asked. The end play, you know, you're going to want to set the end play. We'll go over that. I made a couple of videos on how to do that. And some guys do that different than I do. Some guys set it up before they put the crank in. And some guys do it like I do. So I think I got everybody's question answered on the Volkswagen stuff. Some of you guys are bored to death. But yeah, but if you have any more questions, just give me a call. The piston cylinders, it's a garbage truck. Piston cylinders look a little worn, but you know, if you gotta use them, you gotta use them. Get you some rings, hone them, and you'll be okay, you know. The crank, get some 320 emery cloth, mechanics cloth, and you can polish those journals up. They'll polish right up. Same with the cam. You can use some of that to polish your camshaft. The mechanics cloth comes in a white box. 3M makes it. I think Norton makes it, and it's like a ribbon type, so you can you know, get some polishing action going on. If you want to make a crank stand cheap, let me see if I can get this in here. There we go. If you want to make a stand for your crank, you can get an old gland nut like this and weld it to a piece of steel, and then you can thread your crankshaft onto that, and you can put all your rods on, your bearings, build your crank, you can polish it, and it's a good way to have your crank where you can work on it, service it. You know, if you got a metal bench, or you know, put it on the back side of your engine stand, something, you know. So that little tip might help you. And then when you go to reassemble, you'll need to make some lifter clips. Some of those. You'll need to, you can buy these, or you can make them out of coat hangers. And what they do is they go in and they grab the lifters to keep them from falling out of the case when you flip it over to put the two halves together. So you can make these out of steel clothes hangers, or you can buy these in the Bug Pack or Scat catalog or MP catalog. This is the puller for the gears. You know, a little dusty there. It'll pull a type 1 or a type 4. You just flip it over, it does both. But anyway, you know, it just goes over the gear after you take the snap rings off, and it'll pull the gears off the crank. The other way, I've seen people put them in the press and use a bearing you know, device. I don't know what those things are called. They spread apart. They've got the thread rod on both ends, and they're tapered. You can use that and press the crank out of the gears. You'll heat the gears back up and install them. You'll have to heat the brass gear up, and you'll have to heat the crank gear up also. All this stuff is on video, so if you go back into the old stuff, you'll see them. As far as torque stuff, torquing, the rods are 27 foot-pounds. Your case half nuts and the main studs are 27 foot-pounds. Your 8mm are 18 foot-pounds. Oil pump's 18. And your gland nut on the flywheel is as tight as you can get it. So, and if you want the actual torque, I think it's like 250 foot-pounds. So it's super good and tight. That should cover all the torque specs that you'll have to deal with. You know, yeah, I think it covered everything. You want to make sure your landing is good, where your cylinders are going to sit. Silicone, you know, use the silicone if you want. When I send your heads back, I have some sealer. I can send you one of these tubes that our brother Anthony sent me from Toyota. This stuff's really good. You can use this on your case halves. A lot of times you said that you took the motor apart and found silicone in there. You want to be careful to put your silicone more towards the outside than the inside. You know, it's okay if it oozes out this way, but you don't want it to ooze in and get into the oil pump and, you know, stuff like that. On a stock motor, you'll run a strainer, so you know it will catch the silicone. But yeah, so I think that covers everything, Greg, and whoever else is watching this. The oil pump cover. Somebody asked me if you could use these over, and I usually use these over one time. You'll see where it's run here and here. You can see the gears. What I'll do is I'll turn it, and now the gears will be running on a new surface. So I use them, you know, one time over. If you take it apart and it's got, you know, wear marks, then, you know, you're going to have to get another cover or sand this flat on a piece of belt sander, you know. The oil pump nuts, I always use the red lock nuts on the oil pump cover. The same type of nut that we use on the case half, but instead of the nylock facing up, on the oil pump cover, you use no washer and the nylock goes down, just on the oil pump. If you want, I can pick that up at Triangle for you. You can get the 8mm hardware at any Lowe's or whatever. That's what I usually do, and I just buy the case nuts, the main stud nuts, and the oil pump nuts from Triangle. They're pretty reasonable. So I think that's it. As far as tapping and inserting the case, if you want to do that, you can. Obviously, you don't have any issues with the studs in there. They seem to be holding very well. That's a sort of a safety thing. It's one of those things, you're fixing a problem that you don't have. Normally, they put the inserts in the case to keep the studs from pulling out. It was a heat issue in the material of the case. What happens is it starts breaking down as the years go by. The magnesium gives up. Compression ratio and heat. Volkswagen realized they had a compression ratio issue. Here's a set of bus pistons with the dishes, in an effort to try to lower the compression. So, when somebody tells you lowering the compression won't take the heat out of the motor, Volkswagen had the same idea. So, I do come across those every once in a while. I got a couple sets of those little dish pistons from Volkswagen. But I've been using all the mall stuff and just putting the spacers under there. So that is a dish piston though, if you haven't seen one of those. And there's a flat top, it's not a huge dish, but it does reduce the compression a little bit. So piston cylinders, you can buy those pretty cheap. There's a couple brands out there, you can pick up in the $150 range. I use the Mollies and they're a little more expensive. I've been trying to put some stuff together to build some rebuilt motors. People don't always have the budget for a brand new motor, or even a rebuilt motor with all the machine work done. So that's why I'm trying to put these motors together. I got a couple of them that I'll assemble like this with some rebuilt parts in them and some used stuff, and try to let them go pretty reasonable. So yeah, that's what's happening here today. Not a whole lot. I gotta get out here and get to work. I gotta get this hood done for Andrea because she's on me like stink. It's pretty much a John Kerry day. A couple little fluffy clouds floating along there. Nothing too major. But yeah, so here's the old race car sitting outside. These new tires don't leak. It's pretty cool. So it's just sitting all pretty there. I got to come back here and get this hood going now. It's a freaking mess. Andrew's like, you're gonna have this hood done, So I got it right here. I'm gonna get on this with some 80 grit, get some etch primer on it, get some epoxy. We'll throw some Bodywork down on it and try to get this out of here by the end of the week, because this guy's going on vacation, somewhere for a month in I don't know, Siberia or something. So if I don't get rid of this thing, I'll have it for 3 weeks or whatever. So that's how it always goes, It's not a hurry and then it's a hurry. But yeah, so that's what we're doing. Got cats to feed and stuff like that. But got the Titan training. I want to say thanks to all the guys that sent me the stuff on the tranny. That really helped me out. I'm gonna order some of those books or look at some of the diagrams. Andrew said there was actually one on there that was this camera is giving me a hard time. Let me get it off here. Shaky cam, sorry guys. But anyway, somebody sent me a manual that I can download or upload or whatever you call it. So I'm gonna check that out. And a lot of guys think it's probably a valve body or a solenoid issue, because the inside of the tranny looks pretty good. So I'm gonna probably go do that, clean the valve body out and stuff, but Andrew said I'm not allowed to work on that. I gotta do that hood, because that's real important to her. So as soon as I get that hood done, we'll get back on the old transmission on there. I got it spread out by the pool, getting some sun back here, and we'll go over the parts, and hopefully that book will give me some troubleshooting stuff to look at. But like I said, I went through everything last night and sort of just, you know, threw it all back in here, and it all looks really good. So I don't know what the deal is. I didn't find any broken pieces or any really indications that, you know, that it wouldn't work. So all the planetaries look good, all the torque trunnion bearings look good, the sun shell's not broke, you know, the band didn't look too bad, you know, everything is smooth, all the sealing rings look pretty decent. So probably a valve body problem or a solenoid issue, like you guys mentioned. Even the bushings are like brand new. You look down in there, you know, haven't got discolored. They still got all the perforations in them, and I don't know, crazy. So normally, you know, you like to see something blue or worn out, and you can see, I mean, you know, they got a little wear on them, but I mean, I don't think that they shouldn't work, you know. They have all the lines and all the steels look good. I don't really see anything out of the ordinary, but hopefully we'll figure that out. And thanks again for all the input on that. So it makes the YouTube garage what it is, man. When a guy can take a tranny apart and guys can help him out and give him good advice, it's really cool. So anyway, special shout out to SRV Jedi Knight there. Appreciate all the information, buddy. I knew that you would be my main information source for sure. So I appreciate all that help, and I'll check those sites out that you referred to. And thanks to everybody that left something for me on this, because I don't think I'd get through this by myself. But I'm gonna let you guys go. There's the pool, still looking pretty good. Might need to go swimming someday in there, you know. Kids have been wearing it out. It's great babysitter in the summertime. So, all right, we'll let you go with that. Thanks for watching. Sorry about the long ass video, Greg. I hope it helped, and I hope the guy with the smog conversion, I hope that helped you. And again, my number's 386-216-4626. If you need to call me, call me. That's the easiest way on the phone for me, because I'm not good at spelling, being that I'm dyslexic. So we'll talk to you guys later.